Hey guys, I am an educator at Unacademy Learning Platform, and there I have started making videos which are totally dedicated for CSIR net preparation. So if you are preparing for the exam, I'll recommend you to watch my videos over there. I'll be solving previous year questions, I'll be giving you tips and tricks and many more interesting stuffs which you will get over there. So all you have to do is install this Unacademy Learning app, and you have to search for my name, that is Nurul Huda, in the search bar. Alright, and you can also click on the link given in the description. From there you can directly go to my profile. All right, and for now let's continue with our topic.
Hello everyone and welcome to the channel. So many of you have requested me to make video on phase equilibria, and many of you wanted me to to explain this phase equilibria. So that's why I have decided to make video on this topic today. So see, this topic, if I'll go in very detail of it, if I'll try to explain it in very detail, then this will take a lot of time to explain me. All right, because phase equilibria is related to thermodynamics, and then lots of derivations are there and all. But in this video I'll be giving you that much information from phase equilibria which will be sufficient for you to solve any question in your CSI net exam, and I'll be solving few questions as well at the end of the video. Okay, so if you follow this video, if you understand the things which I am explaining here, I hope that in the next exam as well, if you like this thing, I have already, like, while I was studying, I have studied this much only, and this much has given me marks in my exam. All right, so I hope that this information will be enough for you to score marks from here. Now coming on the marks, how much marks question comes from phase equilibria, so it depends. Like earlier it was like 4 marks question was coming on this topic. From few years I have seen that either from 2 marks or either from 4 marks they can ask you. So I'll be explaining you the topic. So see, now let's move on to the explanation. So this thing, that is phase equilibria, is like, this is totally dependent on this equation, that is Clausius-Clapeyron equation. So for general, like the for doing the numericals and all, from the thermodynamics point of view, this equation is very important. This first one, that is ln of P1 by P2 is equals to delta H vaporization upon R 1 by T2 minus 1 by T1. Here delta H is your enthalpy of vaporization, T2 and T1 are temperatures, different temperature at which the solid and gas phase are in equilibrium, and these P1 and P2 are like pressure. All right, so but when we are talking about your phase equilibria, for that this equation comes into play, where the equation is given by dP by dt is equals to delta H by T delta V, where delta V is change in volume, delta H is change in enthalpy, dP is change in your pressure, and dt is your change in temperature. Now the phase diagram is always like, the phase diagram is on the x-axis you have temperature and on the y-axis you have pressure. So always it's like that, only the graph is between pressure and temperature, and the slope of the graph and all you will get like this. All right, so dP by dt is nothing but the slope of the graph. All right, so one more formula for this is dP by dt is equals to S2 minus S1 upon V2 minus V1. Okay, so what this Clausius-Clapeyron equation is, so it's a differential equation which gives interdependence of pressure and temperature along the phase equilibrium curve of a pure substance. Now the thing which is very important is the substance should be pure. The other thing is that it gives interdependence of pressure and temperature. So pressure and temperature are interdependent on each other. So from this equation you can understand this thing, and it is applicable along the phase equilibrium curve. Like on the curve, this equation is valid. Okay, so so I'll just start this thing with the phase equilibrium diagram of water and carbon dioxide, which is very which are very essential to understand, because question are asked basically from there only. All right, so here is the phase diagram of water and carbon dioxide. This is for water and this one is for carbon dioxide. I have just printed it from Google so that I can explain you guys. Okay, so see, in this both of the phase diagram, you can see that on the x-axis temperature has been plotted, and on the y-axis we have pressure. All right, now the basic difference between these two graphs is the slope of this line. Okay, so this line, see, what are these things? Solid means the water is in solid state over here, like left side of this line is water is in solid state. Now at the right side of this line we have water in liquid state, that is water, here it is ice, and at the lower area is for gas. So these are three different areas. All right, so solid, liquid and gas. Similarly for your carbon dioxide also, so this is your solid area, this is your liquid area, and this is your gas. So both of the lines are same. These are called one single component graph. All right, the component is single over here, that means only one thing is taken, either water or carbon dioxide. So that is your single component system. Now in this case, what is happening here? See, the slope of this line is negative while the slope of this line is positive. All right, because the slope is positive because it is more like bent towards the x-axis, so it is called a positive slope, and whereas this is called a negative slope. So slope over here is negative and slope here over here is positive. That means for water molecule we have a negative slope, solid liquid slope is negative, whereas for carbon dioxide we have a positive solid liquid slope, or you can say the melting slope, because when solid will convert into liquid we have melting. So let's understand the processes which are happening here. So between this slope, that is solid liquid area, the line which is between these area is your melting line, because solid is converting into liquid, both are in equilibrium at this point. So this is called your melting line. All right, or so this is called your melting point, sorry, the curve for melting. Now this over here is between your solid and gas, that means solid is converting into gas, that is your sublimation. So this curve defines your sublimation. And now this curve over here, this one is your like solid, liquid and gas are in equilibrium over here. So on this curve liquid and gas are in equilibrium, so that means on this curve liquid is getting converted into gas, and gas is getting converted, or vapor is getting converted into liquid. So both are in equilibrium. This is called your vaporization. So this is your vaporization curve, this is your melting curve, and this is your sublimation curve. Similarly for carbon dioxide as well, both the things will be same, the curve will denote the same. This will be your sublimation, this will be your vaporization, and this will be your melting curve. All right, okay. So now the thing which is very important, the very basic thing which has been already like always asked in CSIR, GATE and many of the exam like your JAM and all. So the question is from the degree of freedom. Now what is degree of freedom? So degree of freedom is the number of independent variables, the variables which you need, that must be specified to determine the system completely. So how many variables you need to define the system, so that is called your degree of freedom. Now to calculate degree of freedom for a single component system, we have a formula F is equals to C minus P plus 2, where C is your number of components needed to describe the system. Is like if it is a water system, then for like phase diagram for water H2O, then component will be one only. If it is for carbon dioxide, that will be one only. That means how many things you are taking. All right, so that is the component. Now P is the phase means that how many in like solid, liquid, gas, these are the three phases. So how many phases are present at that point in equilibrium. Okay, so if you want to calculate degree of freedom at a point, you have to calculate both of these things. So if I talk about the like at melting curve, all right, so if I talk about melting curve, so what happens at melting curve? So how many degree of freedom are there? So F is equals to C minus P plus 1. This is the sorry, C minus P plus 2. This is the formula. So for water we have single component, so C value is 1. At melting point, at melting curve, how many phases will be there in equilibrium? So as you can see at melting line or the curve, solid and liquid both will be in equilibrium. So we have two components here. So the value of P will be 2. So two phases will be there, solid and liquid, two phases. All right, not components. Component will be 1, that is water. So component is 1 and phases are 2, and plus 2 will give you F value to be 1. So the degree of freedom at any curve, okay, I'll just generalize it, at any curve we have F is equals to 1. So degree of freedom at any curve on the curve, all right, it will be 1. Okay, now inside the area, so if we talk about the area, that is this is also an area, this is also an area, and this is also an area. So inside the area, how many degree of freedom will be there? So f is equals to c minus p plus 2. So component is 1 only, because we are dealing with one type of like solution, like one type of component only, that is water or carbon dioxide. So component will be 1. And how many phases are there? In an area we have just one phase, that is inside this area either solid is there, inside this area either liquid or gas. All right, so we have just one phase here. So we have phase is equals to 1 and plus 2, so it will give you 2. So inside any area we have f is equals to 2. So this is also generalized. So anytime the question has been asked on a curve, and if you have to find out the degree of freedom, just give it 1. And if it is asked on the area, any area, all right, so just give the value 2. Okay, now let's talk about what happens here at this point. So this point is called the triple point. So at triple point, what will happen? I'll just do it here. So at triple point, what will happen? So f is equals to c minus p plus 2. So we have single component. How many phases are here in equilibrium? See, all these phases are in equilibrium. Solid is converting into liquid, liquid is converting into gas, and gas is converting into solid. So all these three things are happening here at this point. So how many phases are here? We'll say 3 phase plus 2. So this will give you 0. So at triple point, the phase is, no, sorry, the degree of freedom is 0. So at triple point, we have degree of freedom 0. At on the curve, we have degree of freedom 1. And inside the area, we have degree of freedom. So here we have 2, here also 2, here also 2. On these curves, we have f is equals to 1. And on this triple point, we have f is equals to 0. Similar thing goes for here also. All right. So these things you have to keep in mind. One more thing, that this slope, I already told you that for liquid this slope is negative, while for carbon dioxide this slope is positive. Now why this thing happens? Because in liquid the density of solid is less than that of liquid, whereas in carbon dioxide it is not so. Density of solid is more and density of liquid is less. Only in liquid it is like in water there is that this thing is there, that the density of solid is less than the density of liquid. So that's why this slope is negative. Okay, so few points you have to keep in mind, so that further if sometime question has been asked, you can give answer. Okay, so the point is related to your enthalpy of the enthalpy. All right, so delta H is always positive along all the arrows or all the curves, your or any all the like conversion, like wherever you are getting change, the delta always be positive. All right, now delta V, the change in volume, is negative only for melting, for water. The reason for this is because the density of solid is less than that of water. Now this question was asked in CSIR June 2018, like recently the exam held, and the question was that the negative slope in water, the phase diagram of water is due to, and you were having 4 different options. The options were like because of decrease in density, decrease in volume, decreasing enthalpy, and many more. So the option will be decreasing volume. All right, so volume means the volume change is the reason why the slope is negative. Okay, so change in volume is negative, that means the volume is decreasing. All right, for melting. Okay, so you have to keep in mind this thing. All right, so the question has been already asked from here, but from here question has not been asked, so maybe they can ask question from here. Okay, okay, so one more thing is there, which I hope it has not been touched till now in CSIR exam, and I hope that they can ask question from here. But like this is the detail of phase equilibrium. When you are studying phase equilibrium in detail, then you will get all these things. So this is a 2 component system in which we have 2 components from, like, see what this graph shows. Here you have 100% 2. 100% 2 means you have 2 solids, solid 1 and solid 2. Solid 1 is 100% over here and solid 2 is 100% here. 100% means it is pure here. Now along this curve, during here in this rectangular box, what is there? Solid 1 and solid 2 are in mixture, means both of the solid are present in mixture. Now in this area, along this area, solid 2 is in solid form, whereas the other thing is in liquid solution. All right, means this is converted into liquid here. Now over here in this figure, what is there? Solid one is solid, but other thing is liquid here. Okay, and here everything is converted into liquid. So this is your like two component system, and like here you will get a eutectic point. So this point is called as eutectic point, where both of the solid and liquid all are in equilibrium with each other. So this is your eutectic point. So this topic is itself like very broad. You have to study a lot about it, but I hope by single component system only you can do the questions, because I have never seen question which has been asked from the like two component system. So single component system is well enough to solve any question. Okay, so I hope I haven't like tried to take the more and more aspects of the topic. Now I will try to solve the questions which have been asked, which have been already asked in CSIR exam from this topic. Okay, so I will start from this question which was asked in June 2017, and the question says that a one component system with the associated phase diagram, this is the phase diagram, is not possible because, so this diagram they are saying that it is not possible. Why? Because OB has negative slope, but we have already seen that water is having negative slope, so negative slope is not a problem here. Now OC has positive slope, now OC has a positive slope, so that is also not a problem, because for carbon dioxide we have a positive slope. OB and OC are linear, that means both of the slopes are in a straight line. That is also not a problem, because we have already seen for liquid and for water and carbon dioxide both, that these lines all exist as a straight line over there. Now 4 point says that OB, OC and OD cannot all coexist at given OA. So at this point all of them cannot coexist. Now why this? Why is this? Why they cannot coexist? Let's try to prove it out. So see, at point O, at point O, let's talk about point O. So we'll, since it is a single component system, so we have F is equals to C minus P plus 2, this formula. So if we try to find out the degree of freedom over here, so degree of freedom over here will be how much? See, we have one component system, single component, because it is already given in the question. So this, how many phases are here at point O? 1 2 3 4, 4 phases. So plus 2. So if you will solve it, you will get minus 1. Now F denotes, means F is the degree of freedom, which tells that how many variables you need in order to specify this this system. All right, so how many variable you need in order to specify that system. So F can be 0, F can be 1, F can be 2 or 3, or any of the value, because for 0 it means you don't need any variable to specify the system over here. 1 means you need one variable, at least one variable, either temperature, pressure, or any of the one variable, in order to specify the component, specify the system over here. For 2 it means you need two variables to specify the components, either those two could be either temperature, pressure, or pressure component or temperature component, any of the two variables. Now 3 means you need three variables. Now but minus 1 doesn't make sense. All right, so degree of freedom cannot be negative. So that means this fourth point was the correct point, and this was like, this is not possible, this graph is not possible, because OB, OC and OD cannot all coexist at OA, because what this is making this point as a having a degree of freedom of minus 1, which is not possible in case. All right, so we cannot take it as minus 1 here, so this is not possible. So that's why this option is correct one. All right, so let's solve this question which was asked in December 2016 exam, and this question was for 4 marks. All right, so the question says that the volume change in the phase transition is 0. From this we may infer that the phase boundary is represented by. Now before to that thing, going to the question, let's just quickly check the 4 options. What are the value of slopes here? All right, so if your slope is like pressure and temperature is like this, so if like dp by dt will give you the slope. All right, because change in pressure and change in volume, change in temperature will give you slope, so this will give you slope. Okay, so we have to just check about the slope of this. Now this question can be done with the help of your Clausius-Clapeyron equation, that is dp by dt is equals to delta h upon t delta v. Okay, So this was your Clausius-Clapeyron equation, which I have I talk about this thing in earlier. So see what it says. It says that the volume change in the phase transition is 0. That means it is already given that delta V is 0. So if delta V is 0, what will happen? dP by dt will become delta H upon T into 0. Now since the denominator is 0, so this term becomes infinite. So it becomes infinite. That means the slope becomes infinite, or you can say that tan theta becomes infinite for this. Okay, so it becomes infinite. So slope is your tan theta. We have all read about slope is equals to tan theta. This we have studied in our smaller classes, like in class 10th or 12th. Okay, so we have tan theta is equals to infinite, and for tan theta is equals to infinite, the infinite value for tan theta comes at theta is equals to 90 degrees. So it can be written as tan 90, because theta can be written as tan 90, because tan 90 has value of infinite. That means theta is having 90 degree. That means the angle between the x-axis and the line should be 90 degree. Now if you check here, this line is parallel to the x-axis, or the thing which is present on the x-axis, that is the temperature. So here the theta is 0 degree. In this option, here theta we don't know what is the value, but theta is negative, that all we know. Here also we don't know the value of theta. This is the theta, we don't know about it, but it is positive, that we know. But here we know that the theta is having 90 degree, so theta is equals to 90 degree here. So the correct option for this question will be your option number 1. So see how simple this question was. This could have been done easily by using your Clausius-Clapeyron equation, and this question came for 4 marks. Alright, so like this it was done. Now let's move on to one more question. So we'll take one more question that was from June 2016 exam, and this question was also asked for 4 marks, so it is very good question as well. So the question says that the phase diagram of the compound is shown below. This is the phase diagram of the compound, and the slopes of the line OA, AC and AB are tan pi by 4. So this slope is your tan pi by 4. Alright, so I'm just writing here that OA is equals to tan pi by 4, then AC is equals to your tan pi by 6, and AB is your tan pi by 3. Okay, so this is tan pi by 3. So these were the three slopes given. If the melting point and the delta H of melting are 300 Kelvin, means the temperature is given 300 Kelvin, and delta H of melting, I am just writing it as delta HM. It shows this is delta H of melting. This is 3 kilojoule per mole, or we can say it's 3000 joule per mole. Alright, so this is your delta H of melting. Now they are asking that change in volume on melting is. Now you have to tell the change in volume on melting. Now see, for doing this question, you should know about the phase diagram somewhat. Like, see, we have already studied that this portion shows solid. All right, so this is the solid here, this is liquid, and this is your gas. All right, so this thing you should know for a phase diagram, these all things, what these area signifies. Now you have to tell about the change in volume on melting. Melting means from solid to liquid. So your system is crossing this this line. Okay, so this is in the equilibrium, so you have to just deal with the slope of this line. All right, so you just have to deal with the AB line. Okay, so the AB line, so dP by dt, or the slope, is given as tan pi by 3 for that line. Alright, now let's use this Clausius-Clapeyron equation. The equation says that dP by dt is equals to delta H upon T delta V. Now this delta V you have to calculate the change in volume on melting. So this delta V you have to calculate. T is given 300 Kelvin, delta H is given 3000 joule per mole, and dP by dt is also given. Just we'll put all these values and we'll try to find it out. So dP by dt is your tan pi by 3, delta H is 3000, and T is 300 into delta V. Okay, so this will cancel this out. So delta V is equals to 10 upon tan pi by 3. and we all know that 1 by tan theta is equals to cot theta. So this can also be written as 10 cot pi by 3. So see how simple this question was. This phase equilibria is very simple topic. You can easily score like 4 marks or 6 marks from here by just knowing the basic, very basic things. So this option number 3 is correct option for this question. All right. So this was for your CSIR June 2016 exam. Now one more question I will take, the last question. Okay, so we'll take this question which was asked in CSIR June 2018. I've already discussed about this question in this video only, but let's take this question the whole. The question says that in the phase diagram of water, the solid liquid boundary has negative slope. We have already discussed about it, that the slope of water is negative. So the reason for that behavior can be traced due to decrease in. So what is the reason why that slope is negative? That I have already discussed, but the question has been asked from here. All right. So the question says that the density of the system is decreasing on melting, or the volume of the system is decreasing on melting, or the entropy is decreasing, or the enthalpy is decreasing. Now I have already told you that on any curve delta H is always positive. That means delta H always increases. Now talking about entropy, so entropy, what will happen when something will convert from solid to liquid? In the like motion, the randomness will increase. It can have more movement now. So on melting, entropy also increases. All right. So this doesn't decreases. Now density, we all know that from solid to liquid when we go, like the density of the liquid is more than the solid, so density also increases. So what decreases here? Only the volume. So you should know this thing, that the volume decreases. All right. And the volume decreases only in case of water, when you go on the melting line. All right. So on the melting curve, the volume decreases. So this was the question, and like this was from my notes, like which I have already prepared during my preparation, and the question was directly asked from there. I was also shocked to see that the question was directly asked like that. So I hope that from what I have taught today, maybe the question in the upcoming CSIR net exam will be asked from here only. So let's hope for the best, and the correct option for this question will be volume. All right. So volume of the system decreases on melting, due to decrease in volume of the system on melting. All right. So that's all for this video. I hope you people liked it, and if you like my work, you can subscribe to the channel, and I'm very happy to see your response. Like many of you are commenting your responses, you are giving your likes, so that gives me a lot of motivation to make good videos. And I'll be coming with new topics, and I want your suggestion that on which topic you people want. Like you want more videos on organic, inorganic, or physical. See, organic, I'm not that good in organic. I know that thing. I cannot like explain you everything in organic, because organic, I feel that you have to memorize many things to understand organic. But for inorganic and physical, they can work on the concept as well. So like you can give in the suggestion, like in the comment box, that on which topic you people want me to make videos, so that I can decide my next lecture. All right. So that's all for this video, and I hope you people have followed me on an academy as well. So if you have not followed me, follow me there. There I'm discussing about organic problems, and many questions I have solved from CSIR June 2018 as well, for 4 marks organic synthesis and all I have discussed there. So you can watch those videos. Those are very helpful. Thank you for watching. That's all for this video. Have a good day. Bye bye.